For the morning session, we have first two speakers who are Turing Award winners. Our first speaker is Raj Reddy, who obtained the Turing Award in 1994. And the citation from the Turing Award page says, for pioneering the design and construction of large-scale artificial intelligence systems, demonstrating the potential impact of artificial intelligence technology. Professor Reddy got his PhD with John McCarthy in 1966 at Stanford. Then he had several positions, but he mostly has been working at Carnegie Mellon University, where he was the founding director of the Robotics Institute. And if you know Carnegie Mellon and have been to the Robotics Institute, you know what a fine institution that is. He was also the dean of the School of Computer Science from 1991 to 1999. And I counted the number of people who have received the Turing Award for artificial intelligence work. It's 7 people. You would recognize the names immediately: Marvin Minsky, John McCarthy, Allen Newell, Herbert Simon, Edward Feigenbaum, Judea Pearl, and Professor Reddy. He has been working over many years about speech, language, robotics, and how to integrate all of this into intelligent systems. And he doesn't do small stuff. His projects are large-scale demonstrators of all these technologies. In the last year, he has been working very hard on technology in the service on society. And today, he's going to talk about something that I think is interesting for all of us. There is too much information and too little time. So, Professor Reddy, please.
Good morning. Today, I want to share with you some thoughts about some new approaches to the problem of too much information. Almost all of us face this, and it's been around not just recently. I remember seeing a paper by Herb Simon in 1969 where he was saying we have too much information and scarcity of attention. Wealth of information, he said. Wealth of information and scarcity of attention is the phrase he used. And the presidents of the United States routinely get a daily personalized newspaper because they don't have time to read everything else, so it kind of gets you to the right place. So I want to start there, saying why can't all of us have the same thing, namely get a personalized newspaper? The Bill of Rights for surviving in the information-rich society is given here. If everything was working perfectly, you would get the right information to the right person at the right time, not too fast, not just in time, in the right language, in the right medium, with the right level of detail. And it turns out, if you take this as a research challenge, it is now possible to build personalized apps for each of these requirements so that the information is filtered. The problem is a lot of the information you don't even know exists because you don't have time to read all of it, right? Thousands of newspapers, the amount of information that comes out every day. And so you may miss something that's important to you personally. And so these 6 attributes I've given, 5 of them I believe can be done by what I call cognition amplifiers. Essentially, you know how to do some of these things, what language, at what time. When faced with this information, you would say, don't tell me today, I'll deal with it tomorrow, kind of thing. And the right level of detail and the right information, right level of detail needs some more complex systems that we don't yet have. And that's what I call guardian angel technologies. Things that are looking at things that you don't even know that you have to attend to. And things where you may be given, oftentimes when I get email, there's more than one paragraph, I don't read it immediately. I say, I'll read it tomorrow. And sometimes that tomorrow never arrives, okay? So the reason is you're quickly going through 300, 500 emails, and you just don't have the time. So today's talk then is how to solve this class of problems of given too much information. And I believe we're at a point using appropriate approaches, we can solve these problems by personalized apps that are on your system. And the question, before you can actually attend to them, you need to understand people have strengths and people have limitations. And these things are understood in cognitive psychology fairly well, but computer designers don't pay attention to them. Essentially, they ignore them as for all practical purposes. For example, people make errors. To err is human. We forget. We are impatient. And when we make a mistake, and often we we prefer activities where if I can click with one click instead of three, I prefer the one-click solution. And so if we are designing systems that require me to do 3 clicks, then the chances are I'm annoyed at having to do that, right? So the other parts we'll talk about is what are human strengths that we don't pay attention to, and then the question of too much information and too little time. So what I'd like to now quickly go through is these issues of human limitations and how they cause problems for human beings when they're using computer systems. In particular, we oftentimes accidentally, close the system, and then we lose all the work that we have done. And there ought to be at least a button on all conditions, even if you stop the computer says undo. No matter what you do, you should be able to undo. Conceptually, it's not hard to do. But nobody thinks it's important to put it into any system. And these days, with infinite amount of computing and infinite amount of memory, unlimited undo is an easy thing to do, right? We ought to be doing that. Why do we forget? Why do we make errors? Is the question I asked some of my cognitive psychologist friends. And they say, people remember by repeating or refreshing their memories. And if you have never had to use that information for a long periods of time, that connection gets weaker in your brain, and therefore you lose the indexing structure for that information. That's how you forget. You may know the face and may know the name, but you say, I know that person, who is that, kind of thing. And this is caused by I'm not jumping to the forget, but going back to the errors, why we make errors, it comes from cognitive overload. If you're in a traffic jam, all kinds of things are happening, cognitive overload, that's why we make errors. And there are solutions now, partial undo and control C. That was one of the things that was there in the early systems. You can't do control C anymore. That doesn't stop. Supposing by mistake you initiate a search and it's taking forever and ever, and you can't stop it. There's no way to stop it. And these kinds of system design issues, people in computer system design not being aware of some of the human limitations, don't pay attention to them. I think we should be in the future. And the second issue is to forget is human. We forget, again, this is the topic I was telling about, we lose the indexing structure, and that leads to all kinds of solutions, and including recognition versus recall. That was a major advance at that time, and online manuals. But in general, we ought to have systems where you can ask H and Y, W questions. How can I do this? Or what if I do this, kind of things. And those solutions are not yet there in most of our systems. We ought to begin to think about them. to be impatient. Most of us are impatient, and we essentially, in interactive problem solving, for the simplest thing was in the old days, probably even today, if you want to turn on or turn off Windows, it used to take forever, like minutes. And I was on Microsoft Advisory Board. I was giving a talk somewhere, and I said this, and it appeared. Raj Reddy says, Microsoft is too slow for everything in Wall Street Journal. That is not what I was meaning to say. Whoever is designing such systems ought to be able to do whatever functions they do in the background, rather than wasting my time. And I did calculate, if there are half a billion people turning on a system every day, and they waste half a billion minutes just waiting for this silly thing to come up, you can calculate the total cost annually to the economy, and it runs into tens of billions of dollars. Okay? Just that one design decision by some designer. The same thing was happening at the end. You assume you can turn it off and go away, but it doesn't work. You come back after the next day, it still hasn't turned off because it's waiting for you to say something or other. And these kinds of things, the fact that human beings are impatient and they prefer so-called principle of least effort is not fully appreciated by system designers. And there ought to be a set of laws that are written down saying, thou shalt not. And every person that's designing systems should have to deal with these things. Okay, we have problems, but we also have a lot of strengths. These strengths are, we learn from experience. A computer program, every time it runs, it should learn from experience. It's not. None of the systems now learn from experience. None of the systems tolerate error, ambiguity, and imprecise input. None of the systems exploit vast amounts of knowledge. And none of the systems, that's not true anymore, communicate using speech and language to the full capabilities of the human being, right? So I'd like to show you a video that was made 25 years ago. We still can't do any of these things today. It is surprising, but not because we could not do it, it's just that nobody thought it was that important, namely carrying on a dialogue, just like two human beings would have dialogue. You cannot have a dialogue of that kind because there are all kinds of issues that come up that are good. Can we turn down the front lights?
Morning. Kate here.
Good morning, Kate. It's April 1st, 1997, and the time is 6:30 a.m. Kate News Selection reports new trade agreements between Japan and France affects Paris spring collections, plus 24 other items of interest. Care to browse?
Not now. Mail only, please.
Mail serve here. 43 items, including 26 unopened for 3 days, 12 unopened for 2 days, and
Cancel list. All right. I've been busy.
canceling. Were there further instructions?
Yes, did my SNAP catalog arrive?
I understood catalog. Snap. Checking.
All right.
Enthusiasm detected. Care to view large screen?
You bet.
Did that mean yes?
Yes, switch to large screen.
Incoming VidPhone call. George Smith from Snap Headquarters, Priority 1. You wish to preview Mr. Smith.
Darn.
You've used that before. You care to define it?
No, hold call, preview caller. Oh no, I smell trouble. Ugh. Okay, VidPhone, open connection.
Kate, are you there? I'd rather see you, Kate.
Sorry, George, not exactly dressed for success this morning.
Seen the customer version of our spring catalog yet? Huh?
Yeah, I just got it in the mail. You guys don't exactly waste time.
You did one heck of a job, Kate. One heck of a job. I love that history of the T-shirt segment. Wonderful. Sales are up.
Hey, cut to the chase, George. You didn't stay up all night to call and compliment me.
Kate, you are the best interactive designer in the biz. I mean that from the bottom of my heart. But I got a little emergency here. You know that blue jeans spectacular that you're working on?
Did you know that blue jeans were invented during the gold rush? A major moment in American culture.
Look, I know that your due date was next week, but I gotta move it up.
Don't do this, George.
I need it by today, 5 p.m. We're going into production tonight.
Tonight?
Orders from the top. I mean, our competition is breaking early. They're doing a jeans retrospective, too. We gotta be better. We gotta be first. The future of Snap depends on you, Kate. Oh, and there's something else.
You're changing the concept on me, George.
Oh, no. We gotta take the history of our blue jeans story into the future. End your segment with a forecast of the jeans of the future.
And no one can predict fashion, George.
If anybody can, you can. Come up with something, champ.
VidPhone, get me Sam Gallagher. Try every number. Copyright status?
James Dean image unavailable. Copyright Paramount Studios. Last usage granted at $15,000 to Levi Strauss for in-house promotion, one time only.
Darn.
Alternate suggestions?
Yeah, let's see. Image search, circa 1959. Blue jeans, male, sex appeal.
Searching Nexus. Access other databanks?
Picture perfect, fashion source and alter image.
You asked to be reminded. Search on Alter Image Databank is very expensive and likely to exceed your monthly online budget. Cost is $4.85 per 1,000 image scan.
Just do it. I'll fight that one later.
Searching. Did not understand last command.
Do it, do it, do it.
Understood. Kate, still unable to reach Sam Gallagher. However, the teleconferencing call you requested is ready. Have Snap Corporate Los Angeles and Paris office both online. Do you wish to be seen?
Yes. Preview.
As originator of the conference call, do you wish to choose resolution on live video?
Whatever.
Default settings confirmed. You asked to be reminded, full video from Paris is expensive at $3.55 per minute. A call of less than a minute will exceed your budget of...
Got it. Top resolution on George. Face only on Genevieve.
Understood. Conference call open.
I chose to show you this 5-minute segment is not because it's cute, but because there are some fundamental technical problems in AI we don't yet know how to solve. And I'd like to go through some of them. And almost, basically, we ought to be moving away from wimpy interfaces, windows, icons, mouse, and pointing, to silky interfaces, which we are not there yet. There's not a serious attempt at doing that. That's mainly because we assume all the people using it are educated and have a keyboard and all kinds of things. That half of the population of the world are not educated, don't have access to keyboards. They might have, something simpler like a smartphone, but they can't even read very well in there. So ultimately, we need to think about building systems, and these are all hard AI problems, using speech and image and language in interaction, in dialogue, are things that need a lot more research and effort than we have. The second we don't know how to build systems that tolerate error and ambiguity. We do. It's not something that's ingrained in everything we do. For example, those of us who grew up with, conventional, programming languages like Fortran and Algol, you would submit a deck, and then a day later it would say there was a syntax error, and then you said wait another day before you can actually make a run, right? And these kinds of things, there are many of these things that are correctable, and the modern systems like Google and Word and things kind of give you prediction, saying, did you mean this? And in which case I'll search for that kind of thing. But that is not the same level at which I'm talking about. That's already a great improvement. But we need to think about interactive systems, systems that can talk to you back and forth, dialogue systems, like the ones you saw there. The dialogue systems where if they don't understand, just like people saying, I beg your pardon, what did you say? What does that mean? And then interpret it and internalize it into its knowledge system. That means you need a system that's learning all the time. It's an enduring system. It's all learning all the time. And these kinds of systems can be built, and we are on the verge of it, but right now we don't have it. The systems that learn from experience, incremental, non-intrusive knowledge acquisition. Many of the things that build knowledge acquisition systems, they insist you have to answer their questions right now. Until you do that, they can't go on. But most people don't want to answer these things. They say, we'll deal with it later, So then the last two are kind of postulate the availability and existence of thousands of intelligent agents in support of whatever you're trying to do. Thousands. Imagine that you're walking around with 1,000 microprocessors on your body. Well, it doesn't have to be 1,000, it can be any number with virtualization. But the idea that you would get intelligent help on a continuous basis and advice saying you're going to run out of your money, and tutoring when I don't know how to do, it will kind of say, how do I do this? And what if I do that? Simulating environments of that kind ought to be doable, and they are. We understand how to do it, but they're not part of our vocabulary of systems design today. And finally, intelligent agents. Get me Sam Gallagher, try every number, doesn't mean you're calling every number in Los Angeles. There's a specific intention involved in there. It is not get me doesn't mean you're physically bringing him, you're getting him on the phone. So there's a lot of ambiguity in human language, and you need systems that can deal with that, right? So, by the way, historical note, this, I said it was made about 1991 or so by LSI Logic. That was preceded by, Apple made a similar system called Knowledge Navigator. Those of us who are old enough know about these. And the difference is, Knowledge Navigator didn't make a single mistake. Everything was perfect. But in reality, speech and vision-based systems are errorful. They will occasionally make mistakes. Human beings make mistakes too, and we deal with it. And we have an interactive protocol on how we deal with an ambiguous situations or new words. If I said Brzezinski, you don't know what that is, but you've heard it, So these kinds of things, human-to-human interactions handled very easily, but not so in these kinds of systems. Okay. Last part of my talk is about too much information and too little time. And here, the problem of not having enough time was actually discussed in a paper by Herb Simon in 1969 is when he gave the talk called Wealth of Information and Scarcity of Attention. This was known. Only difference is we now have probably a billion times more information than they had to deal with at that time, and it's going to get worse every day, every year. We get a lot more information, and there's a whole field that I didn't know about called attention economics in the economics field, and they study this problem of lack of attention in the human beings, and so. The idea that even at that time they were saying was you restructure information, you organize, summarize, and hyperlink, and you create overviews and abstractions and summaries and filtering and so on. And Simon went one step further. He says, you should never read newspapers. I said, Herb, you need to read it. He said, why? None of it is useful to you. You should never read newspapers. I said, finally, it took me a week to go back and tell him most of us read newspapers as entertainment, not because we're trying to save time. Most of us watch TV as entertainment. We need, so there's reasons where you might read a newspaper, but it's not because you need to know that information. You need to do that. So the social networks, for example, again, I'm not a member of Facebook. I never signed up for it. I can't stand wasting all that time. But I can understand why younger people, or maybe even older people, are on Facebook for 4, 5, 10 hours a day, apparently, because for them, that is entertainment. And so the issue then is, what are the key principles of information overload? Basically, when faced with information overload, people settle for good enough solutions in preference to optimal solutions. This is the statement, bounded rationality and realizing, that Herb Simon made in the 50s, for which he got the Nobel Prize in economics. Okay? And when human thinking capabilities are overloaded, people use strategies and tactics of optimal least effort computation. Optimal least computation is the study of approximate algorithms. In mathematics, we have iterative solutions, but in algorithms, you can't say, speed up, hurry up. You ought to be able to do that, but we don't, basically. And so the issue here is design of approximate algorithms to find the best possible solution, where I give you limitations on memory, limitations on time, and limitations on bandwidth. Studying those classes of algorithms is something we ought to be doing. We don't do it in a systematic way. It's not something that's respected yet. Limited bandwidth, limited memory capacity. Some of us, 70 plus people, had to deal with it. Most of the computers we were using had only 1 kilobyte or less, or 2 kilobytes in IBM 650. So it turns out you spent a lot of time optimizing for the memory, use of the memory and the algorithms, but it's amazing. So the kinds of tools you need to do are summarization tools and information structuring tools, and autocomplete is a very important invention in our vocabulary. And most importantly, non-intrusive notifications. One of the things I like about iPhones and other things is you get notifications. But the only problem is the commercial companies have taken over the notifications. I get all kinds of junk in there. So I need to figure out a way of saying, by just swiping left or right in an easy way, to design an interface, never show me notifications from this source again, kind of thing. It ought to be possible. We don't do it yet. But so the question is, going back to the Bill of Rights, or right information to the right people at the right time in the right language, what do we need to do? I've been working with my colleagues on 2 classes of intelligent agents, what I call cognition amplifiers and guardian angels. Cognition amplifiers mainly do things you already know how to do. It's like telling your secretary, get me this person, or make me this reservation, order lunch, or do whatever you would say. But that's all the level at which you interact with them. You're not telling them in detail what to do. It's what we call in AI and other times, what to how programming. You tell the system what you want done, it figures out the algorithm. You don't do the algorithm. And it's like Excel. Excel, you give the formula and it computes whatever has to be done. So, so cognition amplifiers do things that you know already how to do, except they do it for you. To give you an example, right now already, if you're using Google or any of these systems, they do autocomplete. As soon as you type 2 characters, it says, is this what you mean? And then you essentially finish it. Do what you mean, what I mean. But you want to expand that to the scope of tasks. As soon as I go to my bank account and I open pay bills, it says, oh, I've already paid your bill, for electricity. You don't have to do anything more. Or, and sometimes it might even do it without, the only requirement, fundamental principle of bill paying and any financial transactions, anything you do you must be able to undo. As long as you can undo, I will empower my agent to do anything they want. But if they're going to do something that gets me into trouble, then I want to be able to approve it. My approval must be non-intrusive. It should not come and say, can you approve, can you approve it? It must just be there as a notification. And all I'm willing to do with my interaction with the computers will be a left or right swipe. Yes or no, nothing else. That's all the amount of interruption I'm willing to tolerate from my intelligent agents. So these kinds of things, your human assistants know how to do. If you're doing something, your secretary or your postdoc have already the protocols of how to do. Our systems don't. And it's unfortunate that we don't think about these kinds of things. But so kinds of things that a cognition amplifier might do are buying and selling, automatically answering your routine emails, and kind of pointing out some interesting, important news items that might show up, and banking, and travel, and so on. A guardian angel, on the other hand, is much more knowledgeable. It looks at things that you will never have time to look at. If there's some unknown event that's going to happen, something as simple as an accident and traffic jams, or as catastrophic as a tornado or a tsunami or something, those types of things, and also issues of things like scarcity of essential resources. You're not continuously looking to see something you're not going to be able to buy some specific ingredient you need. Like in India, it turns out, there's, every so often you get scarcity of onions and chilies. Without that, they can't make anything in India, right? So that turns out to be very important for them. And if they're not there, there's a huge demonstrations and public protests in the whole thing, right? So the assumption here is each one of these Cogs and Gats are very narrow, highly specialized, doing one thing. That's all they know how to do, but they do that very well. If you imagine 1,000 or thousands of such agents, then you have the beginnings of what I'm thinking about for the future. So what do they look like? What is the architecture of these such systems? This is very important. Now, unlike the apps of today, Cogs and masses are personal, mass customized to each individual. And they're designed to be non-intrusive, autonomic, not autonomous, autonomic, like your heart beats all the time without you telling it to do it. These systems are autonomic and device independent. So if they're autonomic and device independent, they can't be on your smartphone because they'll be using up all the battery very quickly. So we have to talk about that. And it has to be device independent. And at the same time, it's always on, always present and always working and always learning and enduring. It's a lifelong learning system. Think of an agent of that kind that's continuously learning your bill-paying behavior every month over a period. So initially it might have some questions, but as long as it can undo, it might just go ahead and do it, pay the bill. You paid the bill last time, now pay it. And these kinds of systems can now be done with cloud computing. You can instantiate one of these processes, stick it in the cloud. It's continuously looking for on all kinds of things on your behalf. It is working 24 hours a day. But even when you're sleeping, then the problem is the following. You're sleeping, you've turned off your cell phone, but some danger is happening. What do? So we need in the future cell phones, wake up call, which, where you, even if the phone is turned off, you must be able to turn it on and say, something is going to happen, you better get to the basement. Those kinds of functionality is not there yet. They will be there. We'll get there because as we get closer to this information overload, it becomes unbearable. People will design these kinds of systems. We already see them in many of these things. So Cogs and Gats monitor, analyze, and learn from experience. They learn not only from their own experience, but learn from the experience of the others. That means they have to share knowledge, but that may violate privacy. So the whole question of anonymization of knowledge turns out to be very important. And data suitably anonymized can be used to learn appropriate responses for every possible situation. And here I list 4 different types of learning that these systems must have. Notice that none of them are deep learning. Deep learning is very important, very central to advances in AI, but it turns out that's one of many things we need to do in learning. And learning preferences by observing user choices. That could be deep learning because you have hundreds of users and thousands of users, and if you can gather the information from everybody. Learning task similarity and user similarity. And learning by error correction is very important. If it makes a mistake and I say no, and that's all I'm willing to say, yes or no, and it has to then figure out what mistake it made and do it itself. And simply learning by clarification dialogue. This is something human beings do all the time. I beg your pardon, what do you mean? Or is that, whatever. And that kind of thing, they will become part of our day-to-day systems. So, the bottom line is, we must do something about our Bill of Rights, of getting the right information to the right people at the right time in the right language. And that can be done today by use of highly specialized apps that filter the information that you see and you get. And these apps also take care of 80 or 90% of the things that you now do because they know your behavior, what things you look at, what things you don't look at. And they, in addition to the spam, you still get enough email that looks like a good email, but I end up deleting 90% of them. And the issue of how you deal with those things, the most important principle in design of such systems is never intrusive. That is the one thing that kills, that is the most important thing that takes up my time. If I want, if I have too little time, I don't want to spend a lot of time with my agents coming in and interrupting me all the time, right? And so there are whole kinds of things that current systems have, like ads at the right now. These can be done, abolishing dialog boxes and so on. I won't go through the examples of these because I'm sure you can come up with similar things. The scarcity of attention implies creation of tools for minimization of the human effort in doing many tasks. And So what we need to think of is auto-completion of tasks rather than text. As soon as you kind of open up, just like the system said in the video, you have 100 unopened emails. What do you want to do? And you can simply say, I don't want to pay attention to it right now, and then go on. And I want these systems to do more than that, answer 90% of that emails or delete them so that I don't have to deal with them. And there's a whole set of other things that cause problems, which require redesign and relearning that has to be avoided. And finally, we need to think in terms of personalized software. Right now, almost all the apps think everybody is one size fits all. We are at a point that these systems can be customized, mass customized to individual users. And this turns out to be a very important basic thing that we need to do. So in summary, I think we are beginning to see from the fog some of the agents or intelligent agents and filters we can create that will do most of the information, to remove much of the information overload that we are facing, and then we only see the right information at the right time, in the right language, in the right degree of granularity. And I think we're there. We can be there. It's a question. Most of them are AI-like problems. We have worked on them, but they have to go away from AI into system design. People that are doing systems must pay attention to them, not AI types. Thank you.
So we have time for 3 questions. So first question, in the middle.
So thank you. I have a fundamental problem with personalization. And this problem is when I make a system personalize me, then the system also defines who I am as a person. By that I mean the ideal system is giving me the right information in the right time, but maybe having information that is from the perspective of the system, maybe not the right information in that time, would disrupt me in my cognitive process and could lead to cognitive growth of my person. So what do you say to that?
Yeah. So basically, many of the current systems don't understand the fact that people, don't want to be interrupted and don't want to be overloaded in different ways. And that's something that system designers have to pay attention to. And I can give you my version of it, but this is not the time. Go ahead.
Okay, so I know you ended with the statement that we should personalize software. I think that's a great idea. What do you think about personalizing at the hardware level, like making particular devices that are more specific to individual people rather than personalizing at the software?
Yeah, there are so-called field programmable gate arrays at the hardware level you can personalize. And maybe there are new technologies I'm not aware of, that will permit you to do other things of that kind. But as we get to 10 gigahertz processors and even 100 gigahertz processors, almost everything can be done in software. So imagine you're working on hardware, but it's really software. And all the microcode that runs many of these systems is software.
I think what you propose lends itself to certain abuses that must be guarded against. I won't go into the loss of privacy. I think we may have lost it in any event. But I want to mention something that Will Rogers spoke about in the 1920s and 30s. People are harmed less by what they don't know than by what they do know that ain't so. And your proposal of personalization affords a reinforcement of what is called the echo chamber. Tell me only what I want to hear and what will reinforce my beliefs even if they are wrong. That's what your computer assistants may end up doing.
Yeah. So I hope the latter is not true. Basically, let us say you're the president and you're getting a daily briefing. If you only get what you want to hear, your assistants are not doing a right job for you. You're supposed to hear everything that's relevant, not what you want to hear. The first part on privacy is a serious concern for me also. I have been kind of trying to come to grips with in various ways. For example, for dealing with illiterate people in orphan languages, I need to collect data. I would like to capture everything they speak into the computer if possible. Now the question is that a violation of privacy? Sure it is. The question is, can I anonymize it, chop it up into small enough breath groups, things so that it will work? I believe we can do it, but even then, if I were on the receiving end, then I'll be concerned. Right now, one of the problems I have with Amazon Echo, which I love for all kinds of other reasons, where you can kind of have a dialogue as a personal agent, is it's all the time listening. The assumption is it only pays attention to the speech in the room when you say, Alexa, do this, or Alexa, play music, Alexa, order something. But what happens if somebody hacks into that system and uses that to kind of capture all the speech that I'm having with anybody in the room, and then it doesn't go to the system, it just gets stored and transmitted to some hacker? It's conceptually possible. So I have been kind of struggling to see what kind of checks and balances can be there where, without throwing away the benefits, we can also make sure we are not violating the personal things. There's another component of privacy I have never been able to come to grips with. As far as I'm concerned, I have no privacy. Everything I do is already known and knowable and being captured. Every phone call, every email, every bank transaction, every credit card transaction, every time I go in the street, my pictures are all captured. They're there. There's only consolation is only a small number of people have access to it. If they want to find out and prosecute me, they can. But every time I kind of don't stop at the stop sign and just drive right through, somebody could presumably do that, but most of us don't. So the question of whatever we call privacy doesn't exist for me, and therefore, given that everything I do is knowable, I even have gone to the extent of giving my password to my students because they're so much smarter than I am, saying, anyway, you're going to hack into my email. Here is my password. You can read my email if you want to read it. Because, so this is a conundrum. We need to have more discussion about what do we mean by privacy, under what conditions. And there are benefits of being able to learn from everybody's behavior is enormous. Excuse me.
Yeah, the other conundrum is what I would call the man-machine tension. And I think we are already witnessing it. You're replacing human beings in their tasks by making machines more efficient and so on. Is there a way to interface this properly so that people don't end up losing jobs and at the same time people become productive? And for me, the best model is what in India we have the STD model, the ISD STD model. These are phone booths where a phone gives employment to a human being and makes his life meaningful. So I feel such discussions and thoughts should go into these design systems.
Right. I agree with you. Basically, we need to pay attention to these advances. However, here is what we need to see. Every revolution that happened, starting with the Industrial Revolution and every intermediate things, led to loss of jobs, a lot of grief and unfairness for certain groups of people. But overall, if you go back and look at, say, the beginning of 1900, I believe 95% or 90% of the people were on the farms. Now, 4% of the people produce all the food, and everybody else has found some other job. So I'm an optimist. I'm hopeful over a period of 20 years, all these people that lost jobs will find some other jobs to do. But there's 20 years of misery. And they say, no, we're going to just give them training. And what we need is guaranteed jobs, where I'll train you and I'll employ you, even if that's all that it means is, taking care of some security or sweeping the streets or whatever it is. But the sad part is people that lose jobs are not good for nothing. People, homeless people that don't want to work, these have work ethic. They work from 9 to 5 every day. They're willing to work. And that's what is painful, because when they kind of not find a job, and they've been trained, and somebody comes and trains them and collects the money, but they can't get a job afterwards. So the so-called training programs without a job at the end is useless. So what you need is kind of combine the two things. Anyway, we can have this dialogue.
Much, Professor Reddy. Let us thank the speaker, and let's move to the next.